let's explore random numbers in MakeCode for Minecraft. I wrote a program that generates random numbers, in particular zeros or ones, and counts the number of instances of 0 and versus the number of instances of 1, just to see how often they would come out 50-50. So as you can see in this example, the last run here was 10 and 10 for 20 generated random numbers, but the prior run was 11 zeros and 9 ones. So it doesn't always come out exactly 50-50, and that's because we're generating a very small number of numbers of zeros and ones. If we were generating a huge number of zeros and ones, we would expect them to be 50-50, at least almost. Another reason it may not be exactly 50-50, even in the huge number, is that these are pseudo-random numbers, that is, generated by computer. So look up pseudo-random numbers if you would like to learn more about this. In the meantime, let's try some more examples. Let's move over to an unused space in our flat world. This is my sandbox world, which I wrote about in another blog. It's very simple. It's flat, has no rain, no weather, and it always is daylight. Okay, let's run. And let's run. We'll generate 20 random numbers each time, and we will have 2 cases. So there they go. The yellow blocks represent zeros, and the blue blocks represent ones. We got 9 versus 11. Well, it's not too bad. It's pretty close. And the next time, wow, we got 15 zeros and 5 ones. That's actually the least 50-50 case that I remember seeing. Of course, it's even possible to get 20 zeros and only 0 ones, but that would be unusual. Okay, let's move again. And this time, let's generate 50 random numbers. And let's only do it once. There they go. It's tall stacks. Look, they're racing. Oh boy, look at that. Okay, how did they do? Okay, looks like we got 27 zeros and 23 ones. Pretty close. Okay, let's do this one more time. And this time we're going to generate 20 random numbers. Whoops. But we're going to do it 5 times. There they go. Will we get a 10 and 10? Let's see. We have a 12 and 8. This time, there they go. We have 9 and 11. Pretty close. Notice how the player moves to the right each time so that we can have another tall tower. And notice that the 2-digit numbers print out to the left at the correct place, and I'll tell you how that was a little hard to do later when we look at the code. Wow, 7 and 13. Okay, done. So now let's look at the code. There's the code. It's hard to look at here because, and we can't write on it to explain things. So we have put the code into Microsoft Notes so that we can write on the screen. Okay, now first thing to notice about this code is that on the chat command run, that's what causes the code to start running. At the top, I say running. That is, you can look to see that it is running. and on the bottom it tells you when it's done. So that's the first and the last things it does. Then, and I always do that because some of my programs run a long time and I need to know what they're doing. And sometimes my programs don't start when I expect them to, and that's because I forgot to start them over in the code, or sometimes for other reasons that I don't totally understand. But I suspect it's when I leave the code window too fast before it's finished compiling. Don't know. Okay, looking at this code, the first thing we see is that there are two arguments in random numbers and in cases. That those arguments specify the number of random numbers to generate in each of the in cases. The first thing you do if you have arguments in any program is check that those arguments are valid, and if not, either stop the program or set them to some default value. In this case, if the number of random numbers is less than 1, I set it to 20. If the number of cases is less than 1, I set the number of cases to 1. Now, an interesting thing about this is you could run the program and not specify the parameters, the arguments. Parameters are the same thing. And then you would be effectively saying run 0, 0. And in that case, it would the default values of 20 random numbers in one case. So that makes it very nice because sometimes you forget to specify the arguments, but it will still run and give you one case of 20 random numbers. Okay, the next thing to notice is that we have a repeat loop. That's the green repeat loop. Okay. This is for the number of cases. So this loop goes way down and runs all this code way down to there. So the guts of the main guts of the program is to run the number of cases. Now the first thing I do for each case is teleport me, the player, to 30 south, and that's so I like to think of the player as facing east, and then south is on the right. So that keeps all the coordinates positive. So I move over to the right 30 places for each case. Then set both of the counts to 0, so these are going to be incremented every time there's a 0 or a 1. Now, the next repeat loop is a small loop, which generates random number 0 or 1 and counts them. So we pick random 0 to 1. Now, in MakeCode for Minecraft, the endpoints are inclusive, so meaning that it can include 0 and include 1. In some programming languages, that's not true, so you have to be careful about that. So we test if this random number of 0 or 1 is equal to 0. If it is, we increase the counts of zeros by 1, and we place a brick on the pile. If it's not, we increase the number of ones by 1, and we place a blue brick on the pile. Now let's look at these pile coordinates. 20 here means that it's 20 to the east. That's why it's a positive number. So we want them to be in front of the player, is the way I think about it, since the player is facing east in my mind. And we want the 20 blocks out from the player. And then let's look at the z coordinate, which is, that would mean it's right in front of the player for the 0 blocks, and the blue blocks are going to be 3 to the right of the player, or 3 to the south. And then the y coordinate, which is the up and down, so we have the count of zeros will change, and so the blocks will go on top of each other. And the -1 is because we want the first block to start on the ground. And then this one, of course, is the count of zeros, high. Okay. Now, the next segment of the code is, once we've counted all the zeros and ones, we are then going to print out the numeral of the count of zeros and the numeral for the count of ones. And then in addition, so that's this segment of the code. So this little segment here figures out, for the yellow blocks, you're going to print the number on the left of the yellow block. And so you need to know where the first numeral goes. Like if it's 10, you would want it to go further to the left, and than it would if it's only one digit. So that's what this Z variable calculates. So we say if the count of zeros is greater than 10, we're going to start it at -12. And if the start of and if the count of zeros is less than 9 or less, we only move over 6. And then we print the number of zeros and print the number of ones using yellow and versus blue bricks. And again, the only difference here is the Z variable. And the blue bricks are always 5 to the right. How did I come up with a 5? Well, frankly, I experimented. I guessed, and then I adjusted it. Okay. The next segment of this code calculates the chances and says them to the kind of log window. And to calculate the chances, you simply total the number of zeros and ones. Well, we know that that's 20, so we could have used in random numbers, but I just did it this way. And then we calculate the probability of 0, which is the count of zeros divided by the total, multiplied by 100, because we want it to be a whole number. Actually, the probability would be the decimal, like 50-50, the probability would be 0.5, but anyway, I wanted to print out times 100 so that we could say that's the chances. And I calculate both of those, and then I have a text variable that I create which joins them together, and then I say them. And then we are done. Okay, let's go run one more example just for fun. So we'll go find ourselves a better place. And this time, let's run 100 random numbers. And let's only do it once. Well, I think I'll just, since it defaults to one time, I don't even have to specify that. So there we go. It's going to run 100. Yay, look at it go. They're racing. Oh my goodness. Oh, zeros are going behind. Gee. Now, could I move the player now and go up to see this more where I can see it? Well, better not, because all the coordinates that I specified in the program are relative to the player. Hey, we did pretty good. We got 47 to 53. Okay, let's just, for the heck of it, run another one of those just right now and move the player to see what happens. Let's run 100, and we'll run it only one time. Now, here they go. Here they go. Now I'm going to move up. Oh my goodness, see? The coordinates are relative to the player. If I move over, oh my goodness, look, what a mess. And even the coordinates for the numbers are relative to the player. So I think we're just getting everything totally messed up. So now you know, if you move the player, if you're using player relative to coordinates, you better keep the player in the same place. And then I'm going to show you just one more thing here. I'm just going to say run, and is going to run just one case of 20 numbers, and because that was the default. So only if you check your arguments and set them to a default value will that work so nicely. So thank you very much. Goodbye.